Hi, in this video, we will be going over question 4 for test 2 in Physics 2211 for spring 2014. So the question is that you have a pot and you have 2 kilograms, which is 2,000 grams of room temperature water in it, which is 12 degrees Celsius. So you stir it and you do 100 joules of work on the water every second. Because it says every second, we have to focus on how many seconds or minutes this actually occurs. So after 15 minutes, the water reaches a temperature of 100 degrees Celsius. And we know the specific heat capacity of water is 4.2. So when you have problems like this, you just have to write out everything that you're giving. The mass, the initial and final temperatures, the amount of work, if there is any, how long it takes for it to get to its final state, and then also the specific heat capacity. So the first question was you have to find delta E, thermal. You know the formula is MC delta T. For mass, you have to make sure it's in grams. So 2,000. And then, it has to be 4.2, and this is giving in a gram-based unit instead of kilograms. So that's why you have to change this to grams. In addition, the final was 100, and the initial was 12, so the change in temperature was 88. Therefore, you get the answer of 739,200 joules because it's energy. So now you have to find Q, which is heat. The formula is final energy equals initial energy plus work plus heat. The only energy is thermal energy, so we can just say thermal energy equals work plus Q. The thermal energy from the part before. In addition, it happened for 15 minutes. So 15 minutes changed into seconds is 900. And therefore, you just minus this from this side, and you get 649,200 joules. Now you have to find and change in energy of the surroundings. So right off the bat, we know the basic equation. Delta E system plus delta E surroundings equals 0. Once again, we know this value based on the first problem. So we know this plus the surroundings equals 0 because of the conservation of energy. Therefore, it's just the negative of delta E system. So you get negative 739,200 joules. So now we have the last part of the problem, which is worth 10 points. So when you're reading this problem, once again, you just write down everything you're given. For example, the mass of the sweet potatoes is 2.26 kilograms, or 2,260 grams. The initial temperature is 25, and the specific heat capacity. In addition, the water was 2,000 grams via the part before. The initial was 100, and the specific heat was 4.2. Once again, for C, it's in grams, so therefore the mass has to be in grams also. So the energies have to add up to be 0. So we have the thermal energy of potatoes plus thermal energy of water equals 0. So MC delta T plus MC delta T equals 0. If you minus the water's MC delta T to the other side, you get, and then plug in the numbers, you get 2260 times 3.14 times the final temperature minus 25 equals, you have to do the negative because you subtract it, 2,000 grams of water times 4.2 times the final temperature minus 100. When you do all these calculations, you get the final temperature to be 65.7 degrees Celsius. Thank you.